All right, hey guys. This is our first video of our online notes, and if you remember back before we left to come home, we were talking about functions, and I know some of us really struggled with what we were going over. So I'm going to take one step back. We're going to kind of start this unit over from scratch because I assume that we've lost a lot of the stuff we learned too. So it happens when you're out of classroom for too long. So before we jump into what a function is, I want to start with a relation, and a relation is just a connection between an input and an output. So relations just say one thing becomes this thing by some rule. They're just connected to each other, okay? We're going to go over a few different ways that we can express and show and represent relations. These are going to include mappings, tables, ordered pairs, graphs, and equations. Sometimes one method is more effective and easier to use than the other. And for our whole first few examples, we're going to use this set of data right here. So this is our first representation of a relation. This is called a table. We've used them lots and lots of times. Hopefully we're pretty comfortable with them. This is a three-way table, so there's really no clear indication what's the input, what's the output, whatever that might be, okay? We've got our artist, the price of each of their tickets to see a show that they're in, and the income that that artist has in millions of dollars, okay? This brings us to our first mapping, our first representation called a mapping diagram, okay? When we see a mapping diagram, inputs are usually on the left. So in this case, inputs are going to be ticket prices, and outputs are going to be incomes. Okay, so our inputs are ticket prices, incomes are outputs. Whew, that was a tongue twister. Okay, now when we do a mapping, we're going to map the input to the output using an arrow. So when my ticket price is 97, my income's 232. So I'm going to map 97 to 232. 94 maps to 149. So we're going to draw an arrow that maps those guys together. 71, 104, 120, 103, 75, 90, and hopefully 73, 85, which that maps up. Okay? Nice and easy, kind of like roadmap, here to there, there to there, there to there, etc. for all of them. Okay? Inputs on the left, outputs on the right. Arrow starts at the input, ends at the output. Ordered pairs. All right, so we've got XY ordered pairs. That's where we usually see ordered pairs, okay? When talking about relations, our input is always the X and our output is always the Y. So in this case, artist is going to be our input and income in millions is going to be our output. Okay, so input, output, X, Y. Our input, first one, we got U2, really awesome rock band. Income in millions is 232. Input of Bon Jovi. Fun fact, my aunt is friends with Bon Jovi. Output of 149 because that's his income in millions. Taylor Swift. I hate Taylor Swift. Fun fact. Output 104. Elton John. Sir Elton John. He's a knight. 103 as his income. Rihanna is 90. Kenny Chesney, country artist. His output is 85. And we have an extra line here because of good times. Okay? Input, output, okay? Graphing. Graphing's just an extension of ordered pairs. We graph ordered pairs on our graph. Every time we graph, our x-axis is always our input. Okay? And remember, this is our x-axis. Our y-axis is always going to be our output. Kind of like our ordered pairs, input, output, okay? In this case, our x is our ticket price, our y is our income in millions. So ticket price here on the x-axis and income in millions on the y-axis. I'm labeling them, it's important, okay? So we're going to plot these ordered pairs. So we've got 97, 232. That's going to be up here. 94, 149. Excuse me. 71, 104. Oops. 120, 103. 75, 90. 73. Ooh, I messed one up. No, I didn't. I'm losing my mind. 73, 85. Okay? So this is kind of like a scatter plot. Those points are all over the place, okay? But we can see input, output. They're all graphed all over the picture. Okay, so this is all representations of the same set of data from this table. We're going to move on to another set of examples. These ones we're going to fill in. So the first one is mapping 5 teachers to their subject. So mapping, right? Our input here is going to be teacher. That's on the left. Output, subject taught. That's on the right. Okay? So let's list off 5 of the teachers that you guys know. You got Miss Whitehill. You got Mrs. Toscano. Miss Colligan. Mrs. Frobe. And Miss Vargas. Okay, there's 5 teachers on the 8th grade team. Let's write some subjects that they might teach. Reading, writing, science, Spanish, math, social studies. Okay. Now let's map each of these teachers to the subject or subjects that they teach. So Miss Whitehill, I teach math, surprise. Miss Toscano, she teaches reading, but she also teaches writing, so she gets 2 arrows. We're going to talk about what that means later. Miss Colligan, she teaches science. Miss Vargas, Spanish. And Mrs. Frobe, social studies. Easy enough, Whitehill, math, etc. Okay? Athlete to the sport or sports that they play. So let's pick like 4 or 5 athletes. So I like Michael Jordan, the true GOAT. Okay? Let's put Shaq, because I can spell that one. Let's put Gabby Douglas. And Aaron Rodgers, because he's my favorite. Okay? So there's some athletes. Let's write down some sports that they might play. Basketball. Football. Baseball. Why might I have written baseball? That's weird. Gymnastics. And who am I missing? Football, basketball, baseball. Nope, that's it. Okay. Let's start with Shaq. He definitely played basketball. Gabby Douglas, gymnastics. Aaron Rodgers, football. Michael Jordan, he played basketball. But do you guys remember when he had that little stint where he played baseball too? So he's going to get 2 arrows too, just like Miss Toscano got 2 arrows. Okay? Input, output, left to right. Input, output, input, output. Okay? We're going to take this data, we're going to turn it into a table. Okay? Input, output. So we got Whitehill. I teach math. We got Toscano. We got her twice, right? She teaches 2 things. Reading. Writing. We got Colligan. Science. Frobe. Social studies. And last but not least, Vargas, and I didn't leave enough room, who teaches Spanish. Okay, we're going to take this data and convert it to the table too. We got MJ. Basketball, sorry. We have basketball first. We'll go in order. Then we got MJ. Baseball. He also played golf. I don't know if that was just for Space Jam or if he actually played golf, but he played golf. We got Shaq. Shaquille O'Neal. Just basketball, I think. We got Gabby. Okay, Gabby is a gymnast. And then we got Aaron, my favorite, football. Okay, American football, to be specific. Okay. Now we're going to practice ordered pairs. We want to list singers and titles of their songs as outputs. Okay, so let's do some Michael Jackson. Okay, Billie Jean. Good song. Another good Michael Jackson song is Thriller. Great song. Great music video. Okay, and let's do one more. Let's do Whitney Houston. Oops, would help if I could spell. Whitney Houston, I Will Always Love You. Would help if I didn't write so big. Boom. Okay, so there's some input outputs. Input outputs. Remember, X is input, Y is output. Okay, And our last practice right here is listing ordered pairs and identifying the input-output for this graph. So remember, input's always the x-axis, output's always the y-axis. So my input here is the year. Output, low temperature. More specifically, in degrees Fahrenheit. Okay? Some input-output ordered pairs. I'm going to put 2000, 12. We can see that point right here. Another one, let's say 2004, 9. It's a little bit below the 10 mark. I know it's kind of hard to see on this camera. It's not the highest quality. And then let's say 2007, 10. Okay. Cool. Those are our different versions of the ways to display a relation. Okay. Real quick, we're going to talk about what makes each of these relations a function. So a function is when a relation has each input mapped to one output. In other words, inputs can't repeat. We had a visual test, if you remember back when we were talking about functions on a graph. The way that we could tell is the VLT, the vertical line test. Okay? That's going to come back into play when we're going through these. We're going to go back through the 8 examples we went through before, and we're going to determine which ones are and which ones are not functions. So looking back at this guy, this one has 3 different categories, so we can't even talk about it because the 3 things are related when relations and functions are just 2 things related. Okay? Mapping diagram. Do any of our inputs have more than one arrow coming from it? Because that would mean that it goes to 2 outputs, 2 different outputs, more specifically. If they go to the same output, that's fine. Okay? Each of these only has 1 arrow coming from it. So because of that, this guy is a function. I'm going to abbreviate that func because they're funky. Get it? It's funny. Okay. Ordered pairs, inputs. Do any of these artists have a different income? Do any of these artists have 2 different output values? No. So this guy's function as well. Okay? And I'm going to circle it so that it's a little more clear. Okay? This picture is a little bit hard to tell because some of our data is super close together. We got 3 points all within 4 x values of each other. So because of that, we're going to have to relate back to what our ordered pairs were up here. And because of that, we can tell it's a function. If we zoom in on some of these points a little bit more easily, or if we were to graph them using another tool, we would be able to see that the vertical line test here would be passed. Okay, so everything about this data makes it a function. We can tell nothing about anything here repeats. None of the artists have multiple of the same things, and none of the ticket prices and incomes repeat. Okay? Moving back to talking about your teachers. Is this a function? Well, let's see. Miss Whitehill teaches one thing. However, because Miss Toscano teaches 2 different classes, 2 different outputs come from the same input, this is a non-function. Okay? Because Miss Toscano teaches 2 things. If Miss Toscano wasn't on this list, and if we put like Mr. Altavilla on this list, it would be a function because he only teaches STEM to 8th grade. Okay? But because Miss Toscano teaches 2 different classes, that's not going to be a function. By the same logic, number 5 won't be as well because Michael Jordan played basketball and he played baseball. He has 2 outputs for his 1 input. If we didn't include his baseball career here, it would be totally fine. He would have only played basketball. That's only 1 arrow, so this would have been a function. However, since we included his baseball career, it's not going to be a function. Not a function at all. By the same logic in our tables, these are not going to be functions either. If we look, Miss Toscano appears not just once, but twice here, okay? Since she appears twice, the input repeats, and it's a different output for each one, okay? That's not going to be a function. Same logic here. We got Michael Jordan 2 times, 2 different outputs. If they were the same output, that's fine. Wouldn't make sense to write Michael Jordan and basketball twice, but if that was the case, it would be. However, since it's not, we have a non-function here as well. Okay, kind of like the opposite of what we saw on the other page. Last 2, Michael Jackson repeats. Michael Jackson, 2 different outputs, non-function. Remember, X is going to be your input. We have a repeat, no good. And last but not least, looking at this picture right here, all of our points pass the vertical line test, so we have a function. That's the only function on this page. Okay, I'll see you guys later. Make sure you do your practice that I send to you on here, and we'll talk next time. See you guys.